Hello everyone, today we are going to start our lecture number 4, heat's capacity and specific heat capacity, which is related to the chapter number 4, heat and thermodynamics. So I hope that all of you are doing well and doing excellent in your studies. So let's begin our new lesson. Heat capacity. What is heat capacity? Heat capacity is the amount of heat energy required to raise the temperature of the given body from initial temperature to final temperature. From initial temperature to final temperature, the energy required to raise the temperature, we call this as heat capacity. So heat capacity is basically the ability of any material. So heat capacity is given by change in heat over change in temperature. Specific heat capacity, on the other hand, can be defined as the heat capacity of a substance as the amount of heat energy required to raise the temperature of 1 kilogram of a substance by 1 Kelvin or 1 degree Celsius. So specific heat capacity is different from heat capacity in terms of weight and in terms of mass, given mass. When the mass is specified, like in 1 kg, then we call this heat capacity as specific heat capacity. It is given as specific heat capacity is given as heat capacity over mass of the substance. And by putting the value of heat capacity, we will get the final formula as change in heat over mass and change in temperature. Therefore, the change in heat energy is equal to the product of mass, specific heat capacity, and change in temperature, where S is known as specific heat capacity of a substance, and its value depends only on the nature of the substance, not on the amount of the substance. Whatever the amount is given, it depends only on the nature and the quality of the substance. Delta, where delta Q is amount of heat energy, delta T is change in temperature, and mass M is mass of the substance. The SI unit for specific heat capacity is joule per kilogram per Kelvin. Heat capacity and specific heat capacity are always positive quantities. So you need to keep in mind that these two quantities are always positive. So the table here, you can see over here, specific heat capacities or different substances are given, and you can clearly see that water has the highest specific heat capacity. It is because of the intermolecular force of attraction. In water, we know that water molecules are bounded together by covalent bonds and hydrogen bonding. Because of hydrogen bonding, the specific heat capacity of water is very high. And you can see over here that specific heat capacity of ice and water is very high as compared to the other substances. It is almost 4,186. From the table, it is clear that water has the highest value of specific heat capacity. For this reason, it is used as a coolant in power stations and reactors. Owing to its high specific heat capacity, the water warms up much more slowly than the land during summer, and consequently, wind from the sea has a cooling effect. Whenever you go to a seashore, you can feel the cooling effect of water. Now you can tell why in desert areas the earth's surface warms up very quickly during the day and cools quickly at night, because we know that in desert areas, the desert is actually the sand is made up of silicon dioxide. Silicon specific heat capacity is very low, so it warms very quickly and it cools very quickly. So that's why at night, the nights of desert areas are very cooler, and the day of desert areas are very hot because of the specific heat capacity of the substance. On the other hand, the term heat capacity or specific heat capacity does not mean that object contains a certain amount of heat. It is basically heat is energy transferred from the object at higher temperature to the object at lower temperature. The correct usage is internal energy capacity. So basically, the specific heat capacity, the correct term which we can use for it is internal energy capacity of a substance. But for historical reason, the term heat capacity or specific heat capacity are retained or used. When two objects of same mass are heated at equal rates, the object with smaller specific heat capacity will have a faster temperature increase. When two objects of same mass are left to cool down, the temperature of the object with smaller specific heat capacity will drop faster. So you need to keep in mind that when object having higher specific heat capacity, it will warm it will require time to get warm, and it will require time to cool down. So when we study the properties of gases, it is more practical to use molar specific heat capacity. Now, if we consider gases, we know that it is quite different from the liquids and solids. So when we are going to use the internal heat capacity or specific heat capacity of gases, it is more practical to use molar heat capacity instead of specific heat capacity. So what is molar specific heat capacity is defined as the heat energy required to increase the temperature of 1 mole of a substance by 1 Kelvin or 1 degree Celsius. It can be written as molar specific heat capacity is equal to 1 over mu change in heat over change in temperature, where C is known as the molar specific heat capacity of a substance and mu is the number of moles in the substance. And the SI unit for the molar specific heat capacity is joule per mole per Kelvin. It is also a positive quantity. If the gas is held under constant pressure during the heat transfer, then it is called the molar specific heat capacity at constant pressure, and it is denoted by Cp. So Cp is the specific heat capacity at constant pressure of any gas. If the volume of the gas is maintained during the heat transfer, then the corresponding molar specific heat capacity is called molar specific heat capacity at constant volume, and it is denoted by Cv. So these are the two terms that you need to keep in your mind. Now, molar specific heat capacity of some gases are given. You can see over here that helium has the lowest molar specific heat capacity at constant pressure and at constant volume, and the highest molar specific heat capacity is of that carbon dioxide. And because of this, you can observe that why the temperature of the earth is increasing day by day, because the increase in the ratio of carbon dioxide we know that carbon dioxide's heat capacity is very high. So if it absorbs heat energy from the sun, in those regions the temperature will get rise. So that's why global warming is increasing. And you can see the Arctic and Antarctic icebergs, they are being melting day by day. So let's do some example. 0.5 kilogram of water is heated from 10 degrees Celsius to 100 degrees Celsius. How much does its internal energy raise? And given specific heat capacity of water is 4,200 joule per kilogram per Kelvin. We know that rise in temperature is almost 90 degrees Celsius, and 90 degrees Celsius is almost equal to 90 Kelvin. And putting the value in the formula of heat energy, we get the final value to be 190,000 joule. Another example is that what is the specific heat capacity of silicon if it takes 192 joule to raise the temperature of 45 gram of silicon by 6 degrees Celsius. Here the change in heat energy is 192 joule, and mass is given, that is 45 gram, and if you convert this 45 gram into kilogram, it's almost 45 into 10 raised to power minus 3 kilogram. Change in temperature is 6 degrees Celsius. Putting the value in the formula, we get the specific heat capacity of silicon is almost to be 711 joule per kilogram per degree Celsius. Now here you can compare that silicon specific heat capacity is very less, and that of water it was 4,000. So that's why sand is made up of silicon dioxide. So its specific internal energy is very less. Internal heat energy heat capacity is very less as compared to water. That's why desert areas, they get warm and they get cool very easily. Assuming that Coca-Cola has the same specific heat as water, that is 4.18 joule per gram per degree Celsius. Calculate the amount of heat in kilojoule transferred when one can, that is one bottle, about 350 gram, is cooled from 25 degrees Celsius to 3 degrees Celsius. So let's do the solution. Specific heat capacity of Coca-Cola is given. Mass is given in gram, that is 350 gram. And change in temperature is almost minus 22 degrees Celsius. We know that change in heat energy. The change in heat energy, it should be, okay. So putting the value in the formula, mass, specific heat capacity, and change in temperature, which is minus 22 degrees centigrade, we get the change in heat energy is almost minus 32,186 joule. This change in energy is exit energy, means that bottle has been cooled down from 25 to 3. So from the cane bottle, almost 32,186 joule of energy is given out from the bottle. So I hope that you have understood the lecture. Okay. Now there is another question that when 600 milliliter of water in an electric kettle is heated from 20 degrees Celsius to 85 to make a cup of tea, how much heat flows into the water? Density of water is given, that is 1.00 gram per liter. Keep in mind that density of water is standard. Is taken as a standard for finding the density of water, and we have studied that density of water is a constant value. So volume is given, that is 600 milliliter, and converting that into okay, no need of conversion. So density of water is 1.00 gram per liter. Mass of water, we can find the mass of water from the density formula. We know that density is equal to mass per unit volume. So mass of water is equal to density multiplied by volume. So it almost comes out to be 600 gram. Change in temperature is almost 85. Final temperature minus initial temperature, it comes out to be 65 degrees Celsius. So putting the value in the equation, we get the change in heat energy to be 163.02 joule. So that amount of energy is being absorbed by the electric kettle. So I hope that you have understood the lecture. Keep studying and take care of yourself. Goodbye.